All right, so for today's example problem, we're going to be going back and using two of those skills that we did yesterday in our bell ringer. Uh, the distance formula and slope formula will be used here to answer these questions. So for example 4, we've got quadrilateral PQRS with vertices given here. Determine whether PQRS is a rectangle. Specifically, it tells us here to use the distance formula to make this determination. Okay, so there's two things that you're going to have to determine. The first thing is determine whether or not it's a parallelogram. Okay, because a rectangle, first and foremost, is a parallelogram with some further specifications. So if it doesn't meet the original criteria of being a parallelogram, then the other things don't matter. Okay, so I first have to determine that it is a parallelogram. So the way that I do that is that I measure the distance from the vertices P and Q, S and R, and then I measure the distance from P to S and Q to R. And this is going to tell me whether or not my opposite sides are congruent. Okay, so if I have the same distance from P to Q that I do from S to R, then I know those two are congruent. If I have the same distance from P to S that I do from Q to R, then I know those two sides are congruent. And that's what you see being done here. Just plugging in coordinates into the distance formula. And in this case, I do have opposite sides that are congruent. So I know that it is a parallelogram. So then I can take this one step further and make sure that it is a rectangle. And so on top of being a parallelogram, there's two things that a rectangle, or two criteria that a rectangle has that a parallelogram does not. And that is that it has 4 right angles, which the coordinates are not going to help me determine anything as far as angles are concerned. And then I also have in a rectangle that the diagonals are congruent. And so that's where my coordinates come in. I can measure the distance from one diagonal to the other, and then measure the distance from the other diagonal across, and I should get the same measure if it is a rectangle. Okay, and that's what you see being done here. So since the diagonals have the same measure, they are congruent, and quadrilateral PQRS is a rectangle. And so I had to first determine that it is a parallelogram, and then determine that it's a rectangle. That's using the distance formula. Okay, we can also use the slope formula to determine whether or not a quadrilateral is a rectangle. So let's look at guided practice here together, and I'm going to kind of show you how I want you to do your classwork and homework problems on this, because the directions say to graph, but I don't want you to actually go through and plot these points. I want you to do what we talked about yesterday and just kind of make a sketch of what you have going on. So here's my coordinate plane, my x and y axis, and then I'm just going to kind of go through and place these points approximately where they go. So negative 10, comma 2 would go about right there. Negative 8, negative 6 would go about right here. 5, negative 3 would be about right there. And 2, 5 would be about right here. And I'm not really worried about, does this look like a rectangle? Does this look like a parallelogram? Not really concerned with what it looks like at all, because I just sketched it out. What I want to do is just get a good visual of which vertices are where and how they relate to the other vertices, so I know what to measure to get my side length versus what to measure to get my diagonal. Okay. In this case, though, I am not concerned with side links and diagonal links because your directions specifically stated to use the slope formula. So first thing I want to do is to determine whether or not this is a parallelogram. And to determine using the slope formula if this is a parallelogram, what I'm going to do is find the slope from J to M and find the slope from K to L and compare them. We learned a while back that the slopes of parallel lines are equal. So what I'm looking for is that the slope of JM and the slope of KL are the same. That would tell me that these two lines are parallel. Then I'm going to measure the slope of JK and the slope of ML. That's going to tell me whether or not those two lines are parallel. All right. So I'll label my points here and start finding some slopes. And I can just label them as slope of JM would be. And let's go up here, label my points for J and M as x1, y1, x2, y2, and plug into my formula of y2 minus y1 over x2 minus x1. And so my slope is 3 over 12, which reduces to 1/4. And then I want to find and compare the slope of KL to the slope of JM. So now coming back up here, I've got x1, y1, x2, y2, and plug into the slope formula. We've got -3 minus -6 divided by 5 minus -8. This is -3 plus 6 gives me a +3. 5 minus a -8 is positive 13. Sure I got that right. Yes. So these two slopes, while they are very close to being the same, are not the same, and I don't have to go any further because JM is not parallel to KL. I already know this is not a parallelogram. And so let's say though, just for the sake of argument, that I did find all of these slopes, and I found that this line was parallel to this line, and I also found that this line is parallel to this line. Okay, well then that would tell me that it's a parallelogram. Okay, so then how would I go the one step further to make sure that it is a rectangle? Okay, well in this case, since I'm specifically using the slope formula, I'm going to be looking at my angles here. Okay, if I can prove that I've got a right angle here, then that tells me I've got a right angle there, because the lines are parallel, they'd be the same distance apart, so you don't necessarily have to go through and find all 4 of these to be right angles. If you find one of them, then by the transitive property and these lines being parallel, then I know the other 3 would also be 90 degrees. Okay, but how can I use slope to do that? Remember that your slope of perpendicular lines is going to be opposite reciprocals. Okay, so you'll go through, find the slope of JK, and then compare that to the slope of KL. And if they were perpendicular, I would want them to be something like this. I would want the JK to be -1/2 and the KL to be -2. This would tell me that these two lines formed a 90-degree angle, and that would be enough to tell me that it's a rectangle. But still, for both of these, whether you're using the distance formula or the slope formula, your first order of business is make sure that it is a parallelogram, and then your second order of business is make sure that it is a rectangle. Okay, I have to do parallelogram first and rectangle second. right. So your classwork for today, and I will let Miss Zentek make the call on whether or not you can work together. She knows how you were behaved yesterday. So if you behaved well yesterday, then maybe she'll let you work together again today. Whatever you don't finish in class, you're going to finish for homework tonight. And this is going to be page 427. Let's do 22 through 32 all. Okay? And I'll talk to you tomorrow.